Welcome to Defense Unicorns, a podcast for mission-focused innovators. We educate, inform, and provide mission heroes with DevSecOps, cybersecurity, and organizational transformation stories from the world's leading problem solvers. I'm your host, Rob Slaughter, and we're excited for you to join us on this journey. Welcome to our show. On today's show, we have Zack Butcher, who's initially from Google and has started his own tech startup known as Tetrate. He's one of the initial developers of the open source product Istio and one of my favorite innovators. Zack, welcome to the show.
Hey, thanks. Glad to be here. Thanks for having me.
Yeah, so why don't you, for our listeners, tell us a little bit more about your background?
Yeah, definitely. So I was one of the original engineers on the Istio project back at Google and helped do a lot of the API design there. So if you've ever, sat down and used some of the Istio networking APIs and you're like, damn, this was really hard, I'm sorry. That was not just me. That was a team effort there, but that was one of the big parts that, and I worked on a bunch of different stuff kind of around that area. So if you've ever gone and used Google Cloud, you probably made a project to start with. I owned project creation for a long time and some of the identity and access management systems there before we kind of moved and started to adopt this architecture that a couple years later we would actually call the service mesh internally. And then, once we had started that adoption internally, saw good success with it, decided to go and implement it in open source as Istio, and I moved into that team as well. And then these days, I wear a whole bunch of different hats here at Tetrate. Like you said, I was the first engineer to join Varun and JJ there to help start the company. And I help lead our product team, but I do a bunch of other stuff, including work very closely with NIST to help write some of the security standards in this space. And so I help write, in particular, the SP 800-204 series, which is the official set of recommendations around microservice security for the federal. So, a couple of different hats here, help with some of the security standards, help do identity and access control research there with this as well, and help drive service mesh adoption across large enterprise as well as, within the government.
That's incredible. Why don't you, for folks, just explain a little bit about service mesh technologies in general and specifically about...
Yeah, so I think it's helpful to go back and maybe look at the set of problems that we had at the time when we started to build this architecture. And that kind of helps maybe motivate why we did what we did and what it does, right? And so there were two big moves that were kind of happening. So one was breaking apart with the adoption of microservices, right? So Google has always been, a pretty tech-forward company, and they had adopted a service-oriented architecture a long time before others, but we're starting to kind of proliferate that into a microservice-oriented architecture as well. And that brought in all the connectivity concerns, that brought in a range of security concerns and similar that I think, a lot of the listeners here that are looking at Kubernetes and similar probably are grappling with a very similar set of challenges, right? Then the other set that we had, and this is where the technical implementation from the service mesh came from, was we had this monolithic API. And I can't say the name because unfortunately there's now a public company that has the name of that internal project that predated it. But we had this monolithic API gateway and every single Google API went through it, right? So if you used Maps or Translate or any of the cloud APIs or anything, and there were a slew of problems there that you might expect. If you have a shared API gateway in your organization, you probably have the same problems, right? There's shared fate outages. Somebody misconfigured it and took down the entire thing. And now everybody's out and not just the one service, right? We had resource attribution problems, right? You can imagine when you're serving like all the API traffic that Google serves, that's a huge amount. And there's a large footprint and it's expensive. And so it becomes very important to be able to track, who spent this where, so that we can do capacity planning, so that we can do chargeback correctly. And then we had a bunch of just locality problems, as we're load balancing and doing API gateway things, and you have a whole lot more services that are communicating, it turns out that those API gateway things, those functions like rate limiting, like authentication and authorization, you actually want in between all your services. And if you have to go out and back in, it winds up being pretty inefficient and pretty slow. And so we wanted to avoid that set of things. We had this proliferation of communication and we had this monolithic API gateway problem. And so we said, how do we start to solve this? And so the idea came to use what's called the sidecar pattern. And it was not original to the service mesh, but it's been used for years in a variety of different places, really commonly for logs. So if you've had a daemon that rotates log files and ships log data off, That's really very similar to the sidecar pattern that we use now, except instead of using it to manage the file system, we're using it to manage network behavior. And that was the key idea. And so we can take that proxy, that gateway, and we can push it right next to the application itself so that we can then implement for, originally inside of Google, it was about implementing that API gateway style functionality. And as we took the problem into open source with Istio, it became very clear that there was a very related set of problems as well that needed to be solved around baseline communication. Inside of Google, that was handled in RPC frameworks and similar, but there's not good general in open source at the time. So Istio was a phenomenal solution for encryption in transit, for an application identity, so that you can actually write, the front end can talk to the back end and not write this VPC can talk to that VPC, because who knows what's in those VPCs and what that means semantically, right? To start to facilitate fine-grained traffic control. So not just connection level load balancing, but let me make decisions per request. How do I load balance? Let me apply security policy so that I can achieve ultimately what now, we're talking about is a zero trust architecture, right? And that's, I think, hugely in vogue, especially in the federal space because of the executive order and the OMB memorandum. I know that's front and center for a lot of people. And so when we start to get into this idea of zero trust, this idea that at every step along the way at my application, I want to be encrypting. I want to authenticate and authorize the communication and the user that's doing that communication. Turns out that's a perfect fit for that service mesh architectural pattern. So that's a little bit around how it kind of came to be and how we got there, and maybe a little bit about what it does as well. So hopefully that's a helpful overview for folks.
Yeah, that's absolutely incredible. To me, technologies like Istio and Kubernetes have fundamentally changed, the entire planet.
Yeah.
And one of the things that's fascinating to me is, years after creation, it's obvious the benefit that they provide, but is it that obvious when you're starting it?
Yeah.
And so, question for you, walk us through what it takes to start a project that changes the world.
Yeah. So first off, I guess the first way to start that is we didn't expect necessarily that it would change the world, right? We definitely hoped that it would do big things, but we had a very specific set of problems that we wanted to solve to start with. And I do think that's a really important feature if you're going to go and tackle some big problem, is you need to have a specific pain point. You can't go do a science project, right? As much as as an engineer, I love it. I want to go play with cool technology. We have to keep it grounded in a real set of problems and a real set of user pain that we can go and address. So that was the first thing, I think, is that, as we looked around the service mesh space, we knew that networking, Kubernetes was doing a lot to solve compute, right? It was kind of helping realize this idea of compute being fungible and really easy. And I don't have this idea of moving from pets to cattle, right, is awesome. And as we were seeing that happen, we saw that networking was becoming kind of the next big bottleneck for people, right? And so that was that sharp pain that we knew was present, right? We knew that there were these interconnectivity problems as you start to adopt a service-oriented architecture. We knew that inside of Google, we had teams of engineers that were investing huge amounts of money in solving this problem, for the organization, and that doesn't scale out, right? And so that's the first bit, is that we had a pain point that we knew was large, that we knew was going to be hit by a large part of the community as well, right? And so that's what gives you the confidence to go, spend the political capital to spin up a project like this, right? And for us inside of Google, it was made easier because of the success of Kubernetes. Right. We had this, project that was, it is continuing and, like you say, revolutionizing the industry. And so we had a lot of political capital to point to the set of problems around networking that Istio could solve and say, hey, look, I think we maybe can go do this again. We're pretty sure that this problem is big enough. We're pretty sure that the industry is at a spot where we think we can start to do it. So that's, I think, in my mind, the single biggest trait that you have to have is you need to be focused on the end user, and you need to have a specific set of pain points, or maybe just one pain point, one big problem, if it's only going to be one, that you can go and solve. And as long as you can stay laser focused on that, you can then listen to that customer, that set of customers, that set of users, and they're going to guide you in the right spot.
That's awesome. Talk to me a little bit about, how long it took you to go from idea to getting approval from your employer to work on, what at the time is a, relatively risky
Yeah.
small project.
Yeah, and so we did, and so it was a pretty small team that spun up to do this. And one of the things we'll probably have you come talk to Varun as well. We did some of the political navigation around getting it started. I got to blissfully skip at least a little bit of that, right? But it starts like most of these things do, which is we kind of had a little bit of a skunk work project that was just a pretty small group of people that built out the proof. Right. And so we had, and this happened, Istio, I think it came out in May of 2017, but we actually started it about a year before. And so that maybe will give it, and when I say it came out in 2017, what I mean is that we had the 0.1 release, the first release in GitHub, right? We started the open source development of it in November of 2016, but we spent the time before, so at that point in November there, we had largely gotten organizational buy-in to at least have a small team funded to go execute, right? And so all through 2016 was proving that initial value, right? So it was us looking and going, hey, there is this networking pain. And hey, we have this sidecar pattern. Again, the name service mesh didn't exist yet, right? The service mesh wasn't a thing. It didn't get coined until William Morgan and Buoyant. They coined it in 2017 as well, I think. So we didn't even have a name for this thing yet, right? But we had, and we didn't call it a sidecar at the time. We called it the envelope because it surrounded the application. So we had this envelope and we had, this networking problem. And so we built out an open source proof that it would actually work, right? Because the stuff that we had before that was deployed across the entire Google infrastructure was very Google specific. And it wouldn't have been useful or valuable really if that was what we just open source, because it was really very specific. And so we knew that we, just like in the same way that Borg, which was the predecessor to Kubernetes, it wouldn't have made sense to open source that because it was so specific. So then the goal was prove that we can actually do this in open source, right? We've had an investment of, more than 100 engineers for years to build the internal one. Can we actually go and build this in public? Can we actually go do, and so prove out that part? Right. And we were able to. And so there was a small group that built out the initial prototypes for people that have followed the Istio project for a while, may remember that there used to be a couple different components. There was Citadel and Pilot and Mixer, these different pieces of it. And so we had the original 3 teams behind those 3 pieces. And we built the prototypes of each of those 3, proved that it could be proved that we could drive Envoy at the time. And keep in mind, Envoy was not actually even released until December 2016. So we started working with Lyft on Envoy even before it was open sourced as well. And so that was part of the proof. Today, it's really obvious. Of course, you would pick Envoy as the proxy to do this. But, at the time, we were looking at Nginx because why wouldn't you pick Nginx to be the proxy? Because Envoy didn't exist, right? And so we built out that proof. And so that was the key point, is that we were able to, as a small group under the radar, while we were floating the idea that, hey, maybe this could happen, that maybe we could apply some of these technologies to solve this problem, we built the proof point that we could, in fact, deliver it. And that got us a lot of the will to be able to then go and implement for real.
That's awesome. Now, talk to me a little bit about Tetrate. Sort of what made you want to leave the comfort of Google and start your own startup, and talk to us a little bit about what is the big idea or big problem that Tetrate is out there trying to solve.
Yeah. So and Google is a very comfy job, right? It's hard to justify leaving, and it took a good bit to kind of convince me. And what it really was, again, identifying a key problem that was obvious to me, to us, to bring myself, JJ, who helped start it. It was obvious to us that it had to be solved, and that problem was this. So as Istio came out, Varun, who's the CEO for Tetrate, was the product manager at Google for Istio and was given the job, go get the initial users, right? Because for an infrastructure project, especially, that chicken and egg problem of, like, are you going to be the first person to bet the farm, that is your infrastructure on this new untested technology? it's a hard pill to swallow, right? That's a lot of risk. And so he was given the directive, hey, go, let's go get a list of users. Let's go track them down and get them to use Istio. And he, came in, and at the time I happened to be the only engineer on the project that worked in San Francisco City proper. Everybody else for Google was out in South Bay. It happened that most of the companies that we wanted to go talk to, in this case, it wasn't really selling because it was, hey, use our open source project and we'll make your life better. So, Google, we weren't trying to get money from them out of it, but just adoption. I was the only engineer in San Francisco. So he said, hey, come along. I need somebody to do some technical sales. Right. And we went and talked to a whole bunch of different companies there, tens of companies, 20 or 30 at least. And, never in my life have I heard a more consistent articulation from many different people using the same words, which is, we came in and we said, hey, look, there's this cool thing, Istio, you should use it. And the first thing they said is, what is it? And I've never heard of this before. It just came out, this is 2017 that we're doing this in the early days. And we said, hey, look, you can, secure your communication, you can control your communication, you can observe it if you're in Kubernetes. And the next thing that they all said is, hey, that sounds great. Like I have a problem. I need encryption and transit. I need fine-grained traffic control. I have outages. I want to be able to canary my services. I need to be able to get insight into what's going on. Everything that you're saying, it checks out. But you told me I could only use it in Kubernetes. I don't have anything that runs in Kubernetes right now. Like I want to have stuff that runs in, but that's not where I'm at today, right? Where I'm at is that all my stuff is on VMs and is the monolith. And I'm trying to figure out how I'm going to get to that spot that looks really cool. And so once I'm there, yeah, I'll definitely use that. It sounds great. But my real pain is, how do I get there? How do I bridge the gap between my legacy and modern infrastructure? That idea, bridge the gap, is a phrase that we heard articulated a ton. Our main product today is Tetrate. So the reason is because it's all about bridging that gap in infrastructure, right? And then the third thing we heard from every single person that we talked to in that set of calls was, who else is using it? And we said, you can be the first. And universally they said, hell no. Although they didn't quite say that nicely. But, we eventually got past that. We got the initial users bought in, right? But that core idea that the real pain that people had was not, hey, I'm in cloud. I'm in a modern cloud native infrastructure. How do I manage it? It's, how do I navigate from a traditional legacy infrastructure that's focused on VMs, that's in a data center, that has firewalls and VPCs and DMZs? And how do I modernize that into that cloud native architecture? And that's the key pain that I need to help bridge. And so that's the insight for us that we wanted to go solve. And we spent almost that year internally in Google kind of pushing on the management to reorient the project to focus on that idea of adoption or bridging legacy and modern infrastructure. Because for us, it seemed like it made a lot of sense for Google, who's behind Google Cloud, is behind and wants to catch up. Hey, how do we do it? Let's enable data center migration. Let's enable people to move quickly into cloud, right? And it seems like it made a lot of sense. And we could never really get a lot of headway there in convincing management and executives, but we were sure that it was a problem because we kept going and talking to new customers, new prospects, and they kept saying the same thing. And so that's what gave us the confidence then to leave the kind of very cushy, very safe spot that was Google, to really go do this. Is we had heard from so many people that this is a problem and we couldn't get the organization to solve that problem. So we said, look, let's go prove it. Like, the proof is in the pudding. Maybe the executives are right and it's not a problem, and I guess we'll go fail. But we're pretty sure it's not. We're pretty sure it's a real problem. And so let's go solve that. Right. And, we're now 4 years later, and that was early 2018 that Varun left first, and I joined him a little bit later. About a month later. And here we are today, 4 years later, right? And we're doing very well, helping with service mesh adoption, and in particular, the big niche and the reason that folks come to us versus some of our competitors is because A, we have, deep expertise and a lot of experience because of the stuff, around Google that I've talked about, but B, because we exactly fit where they're at, trying to navigate into a modern architecture and a modern system from that legacy system, right? This is one of the big reasons, we help write some of the security standards and things, is because we're exactly helping some larger organizations in the world navigate that very sticky, muddy ball.
That's fantastic. You brought up real briefly some of your NIST work and some of the cybersecurity benefits of adopting some of these technologies, both
Yeah.
Istio and Tetrate Service Bridge. Do you want to recap for us some of the, why, from a cybersecurity perspective, does somebody who's going through what I'll refer to as their cloud native transformation, what unique value proposition does Istio and Tetrate Service Bridge bring to the table?
Yeah. So I think the key thing here is that the set of features and functionality that the service mesh brings to play here isn't unique. You must have it to have a successful distributed system. And what do I mean when I say that? I mean an identity for every workload that can be authenticated and used for authorization at runtime. Means to control how traffic moves through your system so that you can do things like canary and upgrade applications gracefully, as well as implement policy. Traffic control is fundamentally a security policy. Availability is fundamentally a set of security trade-offs, right? Versus, an absolutely safe system, nothing can touch, right? And so fundamentally, we have to make realistic decisions on availability versus security. And the service mesh gives us the tools to be able to do that. And then finally, it gives us insight into everything that's happening, all of the traffic that's flowing in our system. And so that's a really powerful set of capabilities to bring to bear on the applications and on security as a domain, right? And so the key idea that we drive home in the NIST papers there is that we want to, if we're going to start to achieve a zero trust architecture, we need those capabilities. We need encryption in transit. Every single request must be authenticated and authorized both at the workload and at the end user level, right? We need all of these capabilities. So now how do you start to achieve them, right? And what we have seen, based on some of the scale at Google, based on the adoption of the service mesh in open source as well, that the service mesh as an architecture is a really effective way to achieve those kind of necessary features. And so some of that, and why is that the case? Because we can drop in that sidecar, that proxy, next to an application most of the time without having to change that application, because we're interacting at the layer of the network. And we redirect all the traffic into and out of that application through that sidecar proxy. And what that really does more than anything is it gives us that policy enforcement point. So if we're going to drop into some of the NIST parlance, when we have an access control system, we have, PAPs and PIPs and PDPs and all this, this policy machine language around. And, one of the most fundamentally important ones is the policy enforcement point, right? So that takes a verdict from an access control system and makes sure it's enforced at runtime. And so because that sidecar proxy is intercepting all network communication into and out of the application, we have the opportunity to apply any of the policy that we want, whether that's security policy, whether that's traffic, shaping policy or similar, right? And so this is why it's such a compelling tool set, is that we basically get next to the application that's in the network, if you will, where we can apply layer 7 application layer policy to the traffic that's going through. And that maybe in itself is not necessarily revolutionary. You could do that with an SDK. You could do that with a serving framework, right? So the other key thing that the service mesh brings is a central control plane, so that I can go to one place and change configuration, and that will be pushed to the runtime system basically immediately and have that take effect. So now, for example, to mitigate a security problem or to change the Cypher suite that I'm using or to enable encryption in transit or to rotate certificates, rather than having to go and change my application and redeploy it, I can update configuration. And that can take effect on the order of seconds, right? And so what we get is a much more robust system that can provide a security baseline for whole sets of applications without having to go and change the application itself. And so that gives us kind of the substrate to start to build our security model on top of. And that's a lot of what we're trying to do in those NIST SPs, is outline what the security model for a microservice should be, and then how we can start to implement that. And we do talk about the service mesh specifically because we believe that it is the most compelling way to implement this set of behavior compared to some of the other ones, like doing it in SDK, like doing it at the node level, for example. There's a range of different implementations that you could pick. We're pretty sure that the service mesh is a good first choice. It's not the right choice for everybody, but it's a good first choice to look at. right? For the reasons I already said, language agnostic. We can update it out of band. We have centralized control.
Okay. Well, I'm going to give my description based upon you informing me on a bunch of new stuff. And you let me know what parts of what I said is correct or not. And so, from a network security perspective, traditionally people think of a outward boundary,
Mhm.
in and out. But with the adoption of things like microservices, people are starting to talk about network security within an environment and how applications are communicating with each other.
Exactly.
Um,
And there's one other thing, let me just set up that I think is important. And it's one of these key ideas that underpins zero trust that maybe we don't talk about enough, which is the assumption that the network is already compromised. So that's another kind of key reason that a perimeter-based security model doesn't necessarily make sense today, right? Because if you have the assumption that that something in your infrastructure is already compromised, then you move forward. What are the things you have to start to change? So sorry, go ahead, continue.
No, that is fantastic. And then connecting Istio with Tetrate Service Bridge
Yeah,
is really the acknowledgement by yourself and Tetrate, and I'm sure others, that the reality is that the majority of people who are adopting these cloud native architectures are still trying to balance between legacy architectures and more modern cloud native systems that are designed on top of Kubernetes. And so your focus is really, how do you get the benefits of that sort of microservices like architecture while still acknowledging that you might have, at least a couple monolithic type applications within this system.
exactly. And that's important. It's not just at least a couple. You're always going to have some. This is something that I think a lot of people aren't maybe cognizant of, right? That we're not just in some transition state from like on-prem into cloud and like, 2 years from now we're going to be done, right? Like it's never going to end, right? The norm is that we're in these kind of heterogeneous deployments that we need to span, right? And so, yeah, for us, I didn't talk about Tetrate Service Bridge at all. Thank you for bringing me back. So we talked about the service mesh providing all of those capabilities, and exactly what we do is extend that out to a variety of other environments like bare metal, like VMs, and similar to help bridge that gap. And then the other key piece that we do is facilitate that across your entire infrastructure. Service mesh, Istio in particular, is geared at one Kubernetes cluster, right? Turns out that, if you're actually kind of serious about this stuff, you probably have a lot more than one. And so how you start to weave them together and control them holistically can become a challenge. And so Tetrate Service Bridge encodes that into software, right? The patterns for making a bunch of disparate Istios kind of one holistic unit. And then maybe the bigger part or the biggest part, I should say, is the management over top, right? So we bring a whole bunch of multi-tenancy capabilities there. So I mentioned we do research and access control. And a lot of that access control research powers, fine-grained multi-tenancy. So we can, I mentioned shared fate outages as one of the big problems in the classic API gateway architecture. So some of the things that we do include isolation at runtime so that you don't have shared fate outages because of configuration change, right? You can only go and have permission to change what you own in somewhere. And so that's where, for us, we provide a lot of value on top of the open source project because, we never want to be in that dichotomy of like, do I add a feature to Envoy or Istio, or do I add a feature to my product, right? Because that's not a healthy spot for the project or for the product. We want to be in a spot where the more awesome and cool capabilities that can land upstream, that can land in Envoy, the more things that Envoy can do, the more things that Istio can do, we want that to be able to provide more value for people that are using us on top, right? So that's why we focus on, management, enablement, training. How do you actually go and become successful deploying this and using this in your organization, right? And then a lot of encoding the best practices into a software system that enforces a lot of the security constraints out of the box that, keeps you from shooting yourself in the foot, that kind of stuff.
Awesome. And one of your other products that, I'd love to talk about a little bit is you have another product called Tetrate Istio Distribution, or
Yeah.
Distro, TID. What is the sort of background and what problem is TID helping folks solve?
Yeah. So, and I just said, we don't want to fork Istio. We don't want to add functionality there. So why do we have an Istio distro? Is a great question. And the simple answer is there's a couple different things that we like to achieve with that. One, we're not landing, a bunch of functionality there above and beyond the open source project. It exists to primarily for us to facilitate security patches we have a bunch of customers that update at a variety of different cadences, right? The open source project releases, and it only supports 2 releases at a time, right? And, we have, for example, large financial institutions, places like the DoD are not well known for keeping things updated, for updating rapidly. Although, I know that's getting a lot better with folks like the Iron Bank and similar that are doing good work there in helping, right? And so it's just the reality that a quarterly release cadence for many organizations just doesn't jive with what they need, right? And so we do extended security patching for 14 months, actually, for Istio version, is one of the baseline pieces. One of the second things that we do there is a much more comprehensive set of testing than upstream does, basically emulating every single customer environment that we can to a reasonable degree, right? Obviously, we can't go into the minutia of every environment, but the entire spectrum of Kubernetes runtimes of versions above and beyond we test. And then maybe most importantly for some of the federal audience, one of the big benefits of the service mesh is that you can use it to do encryption in transit for your application. As soon as we're in that realm, then FIPS becomes incredibly important. And so we actually have FIPS validated builds of Istio and Envoy as well, which do quite a bit to smooth over your FedRAMP process because Istio is going to make it very easy to implement encryption in transit across your entire infrastructure. And then B, having the infrastructure components that are doing that already validated for you makes that validation process for your overall infrastructure a lot faster. And then, of course, the support when you're having a SAT day, as well as things like, some of the architectural planning and stuff like that, so you can make sure you're actually, deploying it effectively.
Yeah, that's awesome. And for folks listening, Iron Bank, think of it as a secure container hardening process that gets leveraged across the federal government. The way I'd like to describe it is think of it as a secure Docker hub for the Department of Defense and other federal customers. And one of the other products we're going to quickly just talk about is another product called Big Bang, which the way I'd describe it is how do you take those Iron Bank containers and assemble them in a declarative or everything as code fashion to build really a DevSecOps system that secure infrastructure providers can leverage. And the reason I bring up both Iron Bank and Big Bang, Zach, is that there's a rumor on the street that TID is both through the Iron Bank, and I'm hearing people talk about it actually being fully integrated with Big Bang.
Yeah, we were pretty excited about that because it's been quite a while in the running, but exactly. So, TID is there in Iron Bank. And so especially for folks that are already in public sector that are, starting to do some of the exploration in the space, if your AO has already approved Iron Bank to be used, the TID images there are there, the Istio containers are there for you to be able to pull and play with, right? So you can start to do that right away, including the FIPS builds. We're super, super excited. Exactly like you say, Big Bang is basically an instantiation. It's a set of blueprints as code for how you would go and stand up a Kubernetes stack with Istio in it, with a whole bunch of other kind of battery included system as a really effective and powerful baseline for a zero trust runtime for you, right? And yeah, we're very excited that we should actually start to use pretty soon here, I believe, TID is the default Istio out of the box there. Again, because FIPS is so important, right? And so, and we're not shipping extra bits, it's upstream Istio, right? And so that will become the default for Big Bang as well. So as you're kind of playing with the batteries included platform there, and for folks, especially in the public sector, but a lot in private sector that I talk to as well, go check out Big Bang as a really, even if you're not going to use it directly, as a good set of blueprints with a well-reasoned, pretty well-articulated set of decision points there for how to assemble an architecture. It's really effective. And that's one of the other areas that we help out, with some of the TID things is, some of the security posture in Big Bang and similar, right?
That's awesome. So I'm going to circle back to, from an innovator's perspective, very personal level perspective. Do you personally feel as when you're making these decisions, do you think it was more risk you advocating for and pushing for Istio to start, or do you feel like it was more risk for you when you started Tetrate?
Oh, definitely starting Tetrate because fundamentally starting Istio, we were so at Google, and so what's the worst case that the failure mode is like Istio doesn't catch on. And so I go and transfer somewhere else inside of Google to a, and it wasn't necessarily existential, even if it was so bad that I did, that we got fired because that horrible decision that was Istio. That's, there's plenty of other jobs around this, especially in software. It's not that hard to Yeah. So the downside for us there was not that. It takes, however, when you're at a company spot in a, in a large company where you're working with people that you've known for years, where you're making a company salary, it's really hard to get the activation energy to get over the hill to go and leave and start a new company, right? Or start a new thing. A new project inside the same company could be very similar as well when it's, Google is relatively forgiving about moving teams and things. Some organizations are not. So for us, for sure, starting a company was scarier because there's more financial risk than staying at a big company and starting a new project at the end of the day.
Yeah. So talk to me a little bit about, not only the early days, but even now, even though you guys have been, in existence for 4 years, is it easy? Does it feel as easy as Google or is it still stressful?
Oh, it's still very stressful. I'll let you know if it ever you let me know if it ever feels easy too, because you're doing the same thing. No, I mean I'm sure it is, right? I kind of joke, sometimes it feels like, it's crazy to think that it's been 4 years, right? Sometimes it feels like it's been, just 5 days that we've been doing it. And sometimes it feels like it's been like 20 years and it'll never end, right? And a lot of times those are like back-to-back days, right? You get the highs and lows. I will say, for me personally, there's absolutely no regrets having done it, right? I would definitely make the decision every single time again, because it's been a really rewarding experience seeing this thing grow. It's kind of crazy. We're right at about 110 people now, right? And I remember when like literally the entire company was three of us in the office together. And so the satisfaction from even aside from any of the technical stuff, right? And I like to think we're doing a really good job. I like to think we have a really good product. I like, we have customers that are happy. We have a sales team that's moving. From a company's perspective, I think we're doing very well, right? We're doing about as well as I could have hoped. And so that definitely makes the decision easier. But honestly, for me, the stuff that's very validating about doing it is being able to sit down. And just yesterday, I talked with a new hire that joined our company, right? And he actually wrote his master's thesis on zero trust and Istio, right? And he joined the company. And so I get to sit down and talk with him about what he's going to start to do at the company around zero trust and Istio, right? And so that's where a lot of the really awesome validation comes from. For me, that makes that risk worth it because it was hard. It's a hard decision, and it's stressful, and it's doing a startup in particular. It's a lot more work than being at a big company. I'm sure Rob, and you could attest. Even just doing what you were doing in the airports, where you were running a large program, and you had a lot of the responsibilities that a startup CEO has, even there. But you don't have any of the support infrastructure. You don't have, it's a real challenge, and it's been incredibly rewarding. Right. I don't know if it's necessarily for everyone. I can say I'm very happy to have been, the first person to join Vern and JJ, because even just the difference between being like literally the founding team versus just the first person is a large difference in risk in all. But for me, I'm happy that I do it. There are definitely some days where I'm up late and I go to bed late and I'm like, man, I kind of wish I had stayed at that easier. I kind of joke about retiring back to Google, right? I kind of wish we had stayed easier, but for me overall, it's worth it every time, right? When you get together with the team, when you get to see somebody join and they're super excited about getting to kind of they're on the start of their career or they're at a big milestone joining the company to start to do this new area that's really interesting, and then seeing us actually deliver it for customers, right? So we actually have users and we actually have folks at large companies that are betting on us, right? That are relying, and if we screw it up, they get fired, right? And that's some really good motivation to go make sure that we're successful and that they're successful as well. And so when you've got good people and a good team and a fun and compelling problem, and you've got customers that are betting the farm on you, it's hard not to enjoy it.
Yeah. Well, second to last question, can you get some advice for the listeners? And I definitely don't want to encourage everybody to quit their jobs and create a startup because I think there's a lot of opportunities to innovate within larger organizations,
100%.
whether it's large companies or like the Department of Defense or Medicaid, Medicare. There's a lot of very large organizations that struggle with innovation. And I think within those organizations, there's a lot of risk that you can sometimes take when starting new things. You can sometimes put your career on the line just to start a project, even internal to the company. Of
Yeah.
course, Google is very forward leaning, but not every organization is Google. And so with that context, what advice do you have for the people who are considering or looking at making that jump?
Yeah. I think it goes back to what I've talked about before, which is, you have to have your eye on the pain that you're going to solve, right? It doesn't matter if it's a startup or if it's a new project inside the same, your existing organization. It's largely the same. You need to have the focus on the user and on the pain that you're going to solve. And if you're solving pain within the organization, you're going to be showing value and you're going to go and be successful, right? Because at the end of the day, that's going to be the success criterion that you're going to get judged, whether you're a startup that goes off internally or you're pushing new programs inside of some of the largest organizations on the planet, in the DoD or in Medicare and Medicaid and CMS and similar, right? So keep your eye on the value, right? And you get to the value by focusing on where people are struggling and where there is pain today that's stopping them from doing great things, right? And so as long as you can stay focused on that, you'll go and be successful, I think.
That's awesome. Then last question. You're one of our first guests on the entire show, and I'm super honored. Obviously been following you for some time. You're a good friend of mine and somebody who I very much admire from not only a tech perspective, but an innovation perspective. For those folks listening, why should they keep listening to this podcast?
Well, thank you. First off, thank you. That's really touching. And mutually, I think it's awesome to see the stuff you've achieved, both within the DoD and now outside, right? And so that's the first reason. It's a great reason to go listen. Is not many people have been able to achieve kind of large scale impact within organizations like the Air Force that Rob has been able to, right? And so he brings a phenomenal insight into that. Keep listening because there's hopefully other good guests as well. Hopefully this has been interesting for folks to hear a little bit about the service mesh side, but especially as you're starting to look at security in this space in particular, there's so many different moving pieces, right? And the service mesh is not the end all be all of it. It's just one layer in a whole set and a whole, family and a whole set of solutions that form a platform, right? And so go hear about some of the other ones because I know Rob has some other folks that are going to come and talk about some of these other key layers as well, right? So it's just a great place to come learn good and unique insight because he's been able to do some stuff that somebody else has been able to. So it's a great spot to listen.
Well, thank you, Zach, so much for your time. It was an absolute blast, and thank you so much.
Yeah, thank you. Pleasure.